Right, let's get started. So, topic is collecting and simplifying like terms. So let's have a look at what like terms are and what they're not. So a title of collecting like terms and what is a like term, and then as I'm going along, please write in each term. So write in 3a, leave a space, and write a 3a, and then we're going to discuss whether they are or not like terms. So 3a and 3a, these are going to be like terms, but hopefully you've seen why, and the reason for it is, first of all, they're exactly the same, but the important part to notice is even though the integers are the same, what's important is that a. Okay, so the a over here is what's important because it's exactly the same. It's lowercase, it's to the power of 1, there's no extra things added onto it. So because of that, these are like terms. Next one, we've got a and 2a, very similar to the first one because the a's are exactly the same. The integers at the front, there's an invisible 1 there. We don't need to write a 1 in algebra. These are also like terms because our a's, nothing else is happening to them apart from having an integer attached to them, which means multiply in algebra. Next one, we've got 2a with a lowercase a and then 2a with an uppercase a. These, even though they're the same sort of alphabet letter, because they are not visually exactly the same, one's lowercase and one's uppercase, it makes them unlike. Even though that digit is the same, this is what's important, the unknown variable. Next one, we've got minus 3a and 2a. Now remember what I said, because the integers, the digit in front of your variable makes no difference to whether it's a like term or unlike term. These two, because our a's are exactly the same, are also like terms. Our next one, we've got 4a and 4b. The only reason that you might think they're like is because they've got the same digit, but remember that unknown variable is what's important. Now, because this one's an a and this one's a b, that makes these unlike. We've got 3a and 3a squared. Again, very similar to the previous question, the 4a and the 4b. Even though our digit, the 3, is exactly the same, our variable is not. We've got an a there, a to the power of 1, and then a to the power of 2. So these are unlike terms because they are not the same unknown variable. Even though it's the same letter, this one's to the power of 2. Next one, we've got 2a squared and 7a squared. So these are like terms. The reason for it is because the a squared is exactly the same on both sides, even though the digits are different. Next one, we've got minus 3a squared and 7a squared. Very similar to the first one. Our a squared is the same on both sides, even though the integers aren't. Remember, the integers aren't important. They won't determine whether it's a variable, whether they are like terms or not like terms. We've got 2a to the power of 2 and 2a to the power of minus 2. Even though our digits are the same in the powers, this one's a negative, making these unlike terms. Then we've got 2 to the power of a and a to the power of 2. Because these, even though they've got an a as the unknown variable and a 2 as well, they are in a different format. This one's 2 to the power of a, this one's a to the power of 2, so this makes these also unlike. And finally, we've got x and then the square root of x. Even though the unknown variable is the same, because this is x on its own and this is the square root of x, they are not the same. So that makes them unlike terms. So moving on, I'm going to go through these examples. So if you just want to copy them out as we go along and write in the answers. So we've got a plus a plus a. Okay, these are all like terms. So we've got 3 lots of a, so our final answer will be 3a. Question 2, we've got c plus c. These are also like terms. So we've got 2 lots of c, so our final answer will be 2c. Then here we've got d plus d plus d plus d, but then take away d and then take away another d. So if I break this down, they are all like terms, so we can simplify it all together. But if I break it down, we've got d plus d plus d plus d, and we've got 4 lots of d, so we get 4d. But then we need to take away 2 lots of d. So 4d take away d is 3d, taking away another d gives us a final answer of 2d. Question 4, we've got m plus m plus m plus m plus m plus m. So we've got 1, 2, 3, 4, 5, 6. So we've got 6 lots of them. They're all the same, so we end up with 6m. Question 5, 3a plus a plus a. Okay, remember what I said, that digit in front of the a does not determine whether it's like or unlike. What determines is that variable. So we've got 3a plus a plus a. So we end up with 5a. And then we've got b plus 3b plus 4b minus 2b. So these are all like terms as well because they've got the same unknown variable, nothing else is happening to it. So we'll split it up. So b plus 3b gives us 4b. Okay, so that's that there. Then we're going to add on 4b. So 4b plus 4b gives us an answer of 8b. And then we're going to do that final part of take away 2b, giving us an answer of 6b. Have a look at these examples. Again, copy them down as I'm going along. So let's have a look. What have we got that's similar? So we've got 6a plus 4b plus 2a plus 3b. So what's similar here? We've got 6a is a like term to 2 plus 2a. And then 4b is also a like term to plus 3b. So let's break this down. We've got 6a plus 2a, and we've got 4b plus 3b. So 6a plus 2a gives us an answer of 8a, and then 4b plus 3b gives us an answer of 7b. These are both positive, so to simplify this expression, we end up with 8a plus 7b. Question 2, 5p plus p plus 3p. So these are all like terms. So 5p plus p gives us 6p, 6p plus 3p gives us a final answer of 9p. Question 3, we've got AB plus 3B plus 2B. You'll notice that this one here is on its own. There's nothing else that's AB in our expression. So we've got plus 3B plus 2B, which are like terms, but there's nothing else to that, so we just leave it on its own. So it ends up being AB, and then we can simplify this one. So 3B plus 2B gives us an answer of 5B. Question 4. We've got 4x squared plus 3x plus 2x squared plus 6x. So having a look, what's our like term? So 4x squared has a like term to 2x squared, 3x and 6x. So if we split this up, we've got 4x squared plus 2x squared, and then we've got 3x plus 6x. So if we solve it like this, so 4x squared plus 2x squared gives an answer of 6x squared, and then 3x plus 6x gives us an answer of 9x. Again, they are both positive, so we end up with 6x squared plus 9x. Question 5, 7a plus 3 plus 2a. So what's our like term? 7a is a like term to 2a. Our plus 3 as an integer on its own hasn't got anything else to it. So 7a plus 2a gives us an answer of 9a, and then plus 3, because there's nothing else we can do with that integer. And finally, 6m plus 4n minus 2m plus n. So I've underlined our like terms as we went along. So if we break this down, we've got 6m take away 2m, remembering that that negative sign is attached to that 2, and then we've got 4n plus n. So 6m take away 2m is 4m, and then 4n plus n gives us an answer of 5n. They are both positive, so to simplify it, we end up with 4m plus 5n. Okay, so what I'd like you to do now is to copy out these questions and try them for yourselves. So pause the video and give these a go. Okay, now can you please mark your answers? Make sure that they are marked. And now have a go at this task. The answers to these questions will come at a later point. So copy out these questions and give these a go. Now I'd like you to try these ones. These ones are a little bit trickier. So again, copy out these questions and give these questions a go. The answers, if you could just mark them now, please, are the following. Okay, now we're going to be doing a pyramid. So this is an example, so if you could please copy this example as we're going along. So what we have to do here is add the 2 boxes that will make that top box. Same with here, add these 2 boxes that will make that top box. So we've got q plus 1. So if we add them, we get q plus 1. So q plus q plus 1. Q plus Q gives us 2Q, and then the 1 on its own is just a plus 1. So this one here will be 2Q plus 1. And then on this side, we're adding these two. So we've got Q plus 1 plus Q plus 2. So Q are two like terms, so we end up with 2Q. And then 1 plus 2 is positive 3. And finally, we now add these two to give us that top one. So we've got 2Q plus 1, and then we're adding on 2Q plus 3. So our like terms are 2Q plus 2Q, giving us an answer of 4Q. And then plus 1 plus 3, so 1 plus 3, giving us an answer of plus 4. So what I would like to do now is to give these 6 questions a go.